Here's 5.2, day 2, part 2. We're going to continue with finding the x of symmetry, but now we're going to go ahead and find it when it's given an equation in standard form. This is an example I do want you to write in your notebook. So this example is in standard form. What we want to identify is the value of A and the value of B, so we can then use the formula. So remember, the value of A is the leading coefficient in front of the x squared term. So that is 1. Then the B is the coefficient in front of the x term, which is 7. Then we're going to go ahead and use the formula. The formula says you take negative B over 2A. So negative B over A. That should have a 2 there. So we'll just write it as a decimal, negative 3/2. So our final answer for the x of symmetry is x equals negative 3.5. Let you finish writing that example up. Again, make sure you fix your formula. It should say negative B over 2A. Here is a second example. Now it's not in standard form, but it's what we call vertex form. So we can do this problem two ways. We can actually convert this problem to standard form by FOILing it out, or we can identify the vertex. And remember, the vertex will be coming up next. So let's do this just converting this to standard form for right now, and then I'll show you a faster way later. So we're going to convert this to standard form. So remember, this x plus 3 all squared represents 2 of the same parentheses. And now we're going to FOIL those parentheses. X squared, 3 times x, 3 times x, and then 3 times 3. I'm going to combine like terms. And now let's distribute the negative 4 to all 3 terms. So we get negative 4x squared, negative 24x, negative 36. And then we're going to add the 9 at the end. Now we have one more pair of like terms at the end. Negative 36 plus 9. So negative 36 plus 9 is negative 27. So now we have an equation converted out of vertex form to standard form. So let's identify the 2 pieces that we need to use the formula. The negative 4 and then negative 24. So our A is negative 4. Our B, I just noticed, oh, yeah, that's fine. and then negative 24. All right. I just noticed that formula, I copied it from the last slide too, so it should say negative b over 2a. All right, so let's go ahead and plug the b and the a into the formula. So negative b, and b is negative 24, over 2 times negative 4. Negative, negative turns that to a positive 24. And then 2 times negative 4 is negative 8. Then just reduce that fraction, which is negative 3. So then your answer as an equation is x equals negative 3. If we go out and graph that parabola, that is the imaginary line of symmetry that cuts the parabola in half. Okay, we're going to move on to our last topic today of our lesson is being able to find the vertex point. There's different ways we call the vertex point. Some textbooks use what they call a turning point. It's also going to be your maximum point or your minimum point for your parabola. So think about those word problems that we did in lesson 5.2, day 1. Sometimes they were the highest point on the graph, or sometimes they were the lowest point on the graph when we traced it. The vertex point always lies on the axis of symmetry. To be able to find the vertex point, you first find the axis of symmetry, then you substitute the x-coordinate into the equation and solve for y. We will be practicing this in some examples. So I'd say make sure you just write down what is the vertex. It is the maximum or minimum point, and it lies on the axis of symmetry. I do have an example here for you. You don't need to write this picture down of the graph. The axis of symmetry, notice, is that x equals negative 1. The minimum point on this graph is negative 1, negative 2. That's what we call the vertex. That bullet point. This is the vertex. Again, you don't need to write that example down. All right, here's our first example. I do want you to write this example down. Determine the coordinates for the vertex. Given an equation, y equals x squared minus 7x plus 12. Step 1 is to find the axis of symmetry for using the formula like we did, x equals negative b over 2a. So we have to identify the a and the b from this equation. So a is 1 and b is negative 7. Now we're going to go ahead and substitute it into the formula. So negative b, and b is negative 7, over 2a, and a is 1. Negative, negative is a positive, and then 2 times 1 is 2. We got a fraction there, so I'm just going to convert it to a decimal. So our final equation for the axis of symmetry is 3.5. But we have to continue the problem to find the value of the vertex. Give me some time to finish that step. All right, what that says then is this will be your x value for your vertex. Remember that x value is where it crosses through. We want to find the y value for the vertex. So step 2 is to substitute that x value that you just found in the x of symmetry into the equation, the function, and solve for y. So remember, this is our equation, our function. Y equals x squared minus 7x plus 12. And we're going to substitute 3.5 in for x. So that's 3.5 squared minus 7 times 3.5 and then plus 12. Now 3.5 times 3.5 is 12.25. Negative 7 times 3.5 is negative 24.5. And then we have the addition of 12 at the end. When you add those, combine those terms together, you get negative 0.25. So then we write, as the final step, the ordered pair x, y. So our final answer for the vertex of this problem is 3.5, comma, negative 0.25. I'm going to go ahead and stop there. We're at about 12 minutes.